Hi guys, how are you today? Today's objective is how can we determine the center and radius of a circle? So these first two questions are just warm-up questions. Give them a try and see how you do in a second. So just pause the video, give the warm-up a try. All right, so for number one, guys, remember when you're given the coordinates of the center, if you're going to put your circle in standard form, think the opposite. So when you have -3, it's going to be x plus 3 for the x coordinate, plus we have a positive y of 5. So it's going to be y minus 5 squared is equal to the square root of 5 squared. All right, so you have to square that number at the end, remember? Standard form is x squared plus y squared is equal to r squared. So that is why your answer is 1. Now for number 2, these are the centers and the radiuses. Now, if you feel like you don't need a little bit of review on the Algebra 1 aspect to complete the square, you can skip over this whole section, all right? But I'm going to do a little bit of an explanation for those people that need a little bit of extra support with this topic, all right? So we're going to be double distributing here. Square the given binomials, write the expression in standard form, then write the quadratic coefficient A, the linear coefficient B, and the constant term C. So again, this is all review. Let's double distribute here. I have x plus 5 times x plus 5. All right, and then I'm going to combine my like terms, and I have x squared plus 10x plus 25. I'm going to write my linear coefficient, my quadratic coefficient, my linear coefficient, and my constant term. All right, so let's try the next one. I have x minus 1 squared, double distribute, combine like terms, and I have my quadratic coefficient, my linear coefficient, and my constant. All right, now this next piece is a little bit to unpack. Then use the patterns found in the B and C values. Determine a way to use the linear coefficient B. How can we use B to determine C? How can I use B to find C? For all perfect square trinomials. Now, look at these. How is B and C related? How do I go from 10 to 25? How do I go from -2 to 1? Well, you could think about it, or I could just tell you. What you're really doing is halving the middle term and squaring it. Half and square that middle term. Half of 10 is 5. 5 squared is 25. Half of -2 is -1. -1 squared is 1. All right, so that is how you create a perfect square trinomial, by half square the middle term. Right, so are these perfect square trinomials or not? Does the half square rule work? If I half the middle term, oh my Lord. What we're looking for here is half of the B term squared equal to C, right? So is half of 2, 1. Is 1 squared equal to 2? No. Half the middle term squared, does that equal to C? Is half of 6 squared equal to 9? Yes. Is half of 4 squared equal to 4? Yes. Is half of -8 squared equal to -16? No. This would be +16. So for the next part, guys, all you're going to do is determine the value of C real quick by half the B term, halving the B term and squaring it. So pause the video, do A, B, C, and D to find that constant term at the end, and then we'll talk about the factored forms together. All right, so this is what you should have for all of the values, the missing values. Now, the one I do kind of want to look at is C here. Just because this middle term is not an even number, it's no cause for alarm, all right? It's just 4.5 squared. And 4.5 squared is just 20.25. That's it. Now, let's talk about the factored form because it's been a minute since we've done factoring. All right, so the factored form, what multiplies to 36 and adds to 12? 6 times 6. 6 times 6 equals 36. 6 plus 6 is 12. So the factored form of this would be x plus 6 times x plus 6. Now, this is a perfect square trinomial because these two binomials are the same. That's what we're doing when we create this half square situation. All right, so I'm not going to write it like x plus 6 times x plus 6. There's a more abbreviated way to write it. It is x plus 6 quantity squared. The next one, what multiplies to 9 and adds to negative 6? It's going to be x 3 and 3, but it has to be negative 3. X minus 3 and x minus 3. All right, 3 times 3, negative 3 times negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. All right, so that works out. Again, we're going to abbreviate it. So it's going to be x minus 3 squared. Try D on your own. All right, so this is going to be x minus 10 squared because negative 10 times negative 10 is equal to 100. And negative 10 plus negative 10 is equal to negative 20. It works. What multiplies to the end and adds to the middle. Now, C looks hard, all right? Looks difficult. But are you seeing the pattern? Look at the pattern in all this. You notice how the half of your B term always lands up in that parentheses, right? So what is this going to be? If this half always winds up in your parentheses, it's just going to be x plus 4.5 squared. So evidently what multiplies to 20.25 and adds to 9 is just 4.5. All right, so that is basically what we're going to be doing today. So let us use those steps. We want to show how to complete the square algebraically over here. So all you're going to do, I'll start with this one over here. You're going to add 7 to the other side. We always bring the constant over to the other side. X squared minus 6x plus a box is equal to 7. Next thing we're going to do is understand that we need to complete the square. Let's add some squares, those spaces for the half square part like we did over here, right? We filled something in on this side. That's what we're doing. We're creating perfect trinomial squares. So what's going to go in the box over? Half of negative 6 is negative 3. Negative 3 squared is 9. So 9 goes in both sides. Whatever goes on one side goes on the other side too. Same thing. Look at that half. We want to factor what multiplies to 9 and adds to negative 6. It's going to be x minus 3 squared is equal to 16. That is the form that we want. Okay, so we did that correctly. Pause the video now and get an answer for A. All right, so this is what you should have for A.